This video is not intended as a substitute for your operator's manual. The operator's manual should be carefully read, paying particular attention to the safety instructions. Safety instructions should be followed at all times. Heeston suggests you view this video before taking your baler to the field, and once again after familiarizing yourself with the machine. An index is provided on the back cover of the video to help you find specific information. Heeston pioneered the design of large rectangular balers with the introduction of the 4800 baler in 1979. We at Heeston are proud of the reputation we have gained in the service support of these balers. This video is part of our ongoing commitment to provide valuable service information to our customers. The 4750 and 4900 large rectangular balers are designed to build high-quality, high-density rectangular bales. The 4750 baler utilizes 4 double knotters to produce 32 by 34 inch bales, up to 98 inches long. The 4900 baler has 6 double knotters to produce 48 by 51 inch bales, up to 108 inches long. During operation, these balers are fully automatic, requiring only the tractor driver to operate the tractor baler unit. The balers use electronics to control and monitor the baler operation. This aids the operator in producing quality hay while increasing baler productivity. The 4750 requires 90 PTO horsepower. The 4900 requires 120 PTO horsepower, but for optimum performance, a 150 horsepower tractor is recommended. Crop is picked up and continuously fed into the baler by the pickup assembly. The crop is then moved to the charge chamber area by the packer fingers. The charge chamber preforms the flake of hay before it is delivered into the bale chamber. When a sufficient flake is made, the sensing door will trip, activating the stuffer fingers, which sweep the crop into the bale chamber. The stuffer fingers are timed to the plunger, which compresses the flake of hay into the bale being formed. When the bale reaches a predetermined length, the knotters are tripped to tie off the bale just completed, while the second knot ties together the top and bottom twines to start the next bale being formed. In order to maintain the baler and ensure that it operates reliably, it should be lubricated on a regular basis. The operator's manual shows the location of all lubrication points. Frequency of lubrication is given in number of bales, rather than in hours. The 4750 baler has 79 greased zerks, and the 4900 has 94 zerks. It is better to grease the baler at the end of a baling cycle rather than before, because when the machine is warm, it will accept the grease easier than when it's cold. A centralized lubrication system is optional. Proper use of this system will reduce the time required for daily lubrication. Check the oil level in the 4900 gearbox with a dipstick at the front of the gearbox. The 4750 is a check plug. The 4750 gearbox holds 10 quarts, and the 4900 holds 20 quarts of SAE 80W140 or 85W140 extreme pressure lubricant. Before hitching the baler to the tractor, the drawbar dimensions need to be checked. Set the drawbar to ASAE standards, as shown in the operator's manual. The clevis to attach the baler to the tractor is included with the baler. Standard on the 4750 and 4900 is a 1 3/8 inch, 1000 RPM PTO. Optional on the 4900 is a 1 3/4 inch PTO. Make sure the yoke locking pins operate freely and are seated in the groove on the PTO shaft. Attach the safety chain from the baler to the tractor drawbar support. After the implement drive shaft has been connected, adjust the carrier bearing support bracket as shown in the operator's manual and on the decal on the baler tongue. Remove the jack and store it on the post provided at the front side of the ladder. Connect the hydraulic hoses for the bale density control valve. The pressure hose for the density control valve is the outside hose. Hook it to the appropriate outlet depending on which way the hydraulic control lever is to be locked in the on position. Connect the hydraulic hoses for the pickup lift. Hoses should be hooked to a hydraulic circuit with a float position. The lighting wire harness will plug into any ASAE 7-pin plug. A connector to adapt to European design tractors is available. Refer to the extra equipment section of the operator's manual. Install the control console in the front of the operator so that it can be monitored while baling. The power supply cable should be hooked to a 12-volt source, black wire to ground. The control console must always be attached to an unswitched power source. Hooking to a switched power source can cause loss of non-volatile memory in the control console computer. Connect the main control cable to the baler harness. Install the clamp on the cable to keep connectors from working loose. The bale density control is set up for use with closed center hydraulic systems. To convert the control valve to open center, remove the plug in the valve. Install the open center valve and coil and torque the nut to 5 foot-pounds. Remove the front 2 wires from the storage terminal block and install them on the solenoid. The 4750 control valve is located under the baler tongue. The control console needs to be reprogrammed when the open center solenoid is installed. To do this, turn on the control console. During console power-up, push the reset button. The console should display a CC in the upper display. To change, depress the Scan Select button. The control console will change to OC. Before starting the baler in the field, it is necessary to familiarize yourself with the functions of the electronic control console. The console can be turned on by pressing the on-off toggle switch until a beep is heard. Or if the baler is started up without the console being turned on, the rotation of the baler timing sprocket will automatically power up the console. The timing sensor will also shut the console off if the baler rotation has stopped for 15 minutes. All functions under the screen will display for 4 seconds so the operator can see if all segments are working. The Scan Select button controls the readings on the LCD display. The display will show load as a 3-digit number, pressure as a 4-digit number, and flakes per bale as a 2-digit number. Bale weight will only display on a 4900 with an accumulator and bale weight kit. In the scan mode, each function will show on the display for approximately 4 seconds each. To continue to display one function, press the Scan Select button when the desired function appears. The 3-digit load reading shown on the console during baling is obtained by the load cells on each connecting rod, measuring load each stuffer cycle. This measured load is then compared to the operator's set load. If the plunger load is less than the set load by a predetermined amount, the console will activate the increased solenoid for a preset time, sending oil pressure from the tractor hydraulics to the bale tension cylinders. This moves the bale chamber doors in, applying more force to the bale. If a plunger load is more than the set load, the decreased solenoid is activated, reducing tension on the bale chamber doors. The operator's set load can be checked or changed by pressing the plunger load set up or set down button. A plunger load setting from 130 to 160 on the 4750 and from 260 to 320 on the 4900 is best for most operating conditions. Should the plunger load exceed a predetermined value, the alarm will sound. An overload will flash at the operator. If the overload flashes for 2 stuffer cycles, slow the ground speed to allow the load control to catch up. If the overload continues after slowing down, stop the baler to determine the problem. Check crop moisture and check that the tractor hydraulic system is functioning correctly. If the hydraulic system is determined to be working correctly, set the console on manual and release pressure by pressing the decrease button on manual control until plunger load is acceptable. Then the console can be switched back to automatic. For more information, see the electronics troubleshooting section of the operator's manual. The pressure on the bale tension cylinders is read by the pressure transducer, which is basically an electronic pressure gauge and is shown on the console as a 4-digit number. The pressure reading is useful to the operator in determining crop condition and moisture content. While baling, as the pressure reading gets higher, the moisture content of the crop is lowering. The 2-digit flakes per bale display is determined by the console counting the stuffer cycles between each knotter cycle. The normal range for flakes per bale is between 33 and 55, depending on crop and bale length. When operating below this range in a springy crop such as straw, it's best to reduce the plunger load setting. If operating above this range, check the stuffer clutch to be sure it is disengaging correctly. Bale count is determined by cycling the needles. A switch on the right side of the needle carriage signals the console to count the bale. Pressing the Bale Count button will show field bale count for 3 seconds. Then total bale count times 10 will show for 3 seconds. Field bale count can be reset by pressing Bale Count and Reset buttons at the same time. Both buttons need to be held until the display shows 0. Total bale count cannot be cleared or reset by the operator. Each knotter's cycle, the word knotter, appears in the lower display of the 4900 console. On the 4750, the word tie appears on the display. If the operator would like a short beep to alert him that a tying cycle is in process, press the Bale Count and either Alarm Set button on the 4900. Repeat this process to turn off the alarm. This is accomplished on the 4750 by pressing the knotter alarm On-Off button. The knotter function is monitored by 2 switches on the upper slacker arms. If the knotter malfunctions, the alarm will sound and Check Knotter will flash on the lower 4900 display. The word C-Knot will appear on the 4750 screen. Now, 2 types of knotter misties are monitored. If the bottom slacker arm switch does not close during the knotter cycle, the alarm will flash and sound at the end of the knotter cycle. This mistie is usually caused by the needle missing the twine on the needle upstroke. If the twine is missed to the left of the needle, the twine will be wrapped around 2 bales. If it is missed to the right of the needle, the twine will generally wrap the billhook. The second type of mistie is monitored if a top slacker arm stays up after 5 stuffer cycles since the last tie cycle. This could be caused by a missed knot, twine feeding problem, or running out of twine. When a check knotter or C-knot signals the operator, check the monitor flags for specific knotter malfunction. Should the needle carriage remain in the bale chamber longer than a predetermined period, an alarm will sound and the 4900 lower display will flash Check Knotter Needles. The 4750 display will flash Need. If the stuffer timing sprocket detects that the stuffer knotter drive sprocket has stopped and the baler timing sprocket continues to run, an alarm will sound and the 4900 display will show Check Stuffer and a broken bolt symbol will flash. The 4750 monitor will flash Stuff. If the oil in the gearbox should overheat, the alarm will sound and the Check Gearbox and Oil Temperature symbol will flash on the 4900. The 4750 monitor will flash Gear. On the 4900, the feeder slip clutch display is controlled by the console comparing the timing signals from the baler timing inductive sensor and the feeder slip clutch inductive sensor. For feeder slip less than 10%, a bar and corresponding numbers will appear on the display. For slip from 10 to 20%, an alarm will sound along with the bar and numbers. Slip greater than 20% will produce a continuous alarm. For an occasional feeder slip of less than 10%, ground speed should be reduced. If it is greater than 20%, the feeder system is plugging, and the tractor should be clutched to allow the feeder to clean itself out. On the 4750, if the packer and pickup slip clutches have excessive slip, the word Slip will appear on the display. The stuffer cycle dot is controlled by the stuffer inductive sensor and will flash each stuffer cycle. When baling, it should flash about every 2 seconds. For optimum capacity, the stuffer should cycle every plunger stroke. If this is not the case, the operator can generally increase the ground speed to better utilize baler capacity. Monitoring the stuffer dot is important in assuring the stuffer system is functioning properly. If the stuffer dot does not flash every 1 to 3 plunger strokes when feeding crop into the baler, stop and determine the problem. On the other hand, the stuffer dot should not flash every plunger stroke when crop isn't being fed into the baler. If this happens, generally the stuffer door is out of adjustment or binding. Serious damage to the baler can occur if the stuffer is not operating correctly. Careful monitoring of the stuffer dot allows you to immediately identify problems with the stuffer mechanism. The driving meter arrows are on each side of the stuffer dot. 1, 2, or 3 arrows indicate to the operator the degree of correction required. If only 1 arrow appears occasionally, no driving correction is usually required. The meter works by the console comparing the load differences on each connecting rod load cell, then indicating to the operator when the correction is needed. Most common baler malfunctions are monitored by the console, and the operator is informed of these by an alarm and a check number displayed. A complete list of check numbers and their meaning are listed in the operator's manual. Reference this list when a check number appears. Manual control of the baler is provided for emergency use only. For manual operation, a toggle switch at the back of the console should be switched down. The console will display off in the scan mode along with load, pressure, and flicks per bale readings. By using the remote load control rocker switch, the operator can increase or decrease pressure on the density cylinders by actuating the increase or decrease solenoid. In the manual mode, the operator must monitor the load closely to prevent an overload condition. The 4750 and 4900 have a twined storage box on each side of the baler. Total capacity is 16 balls on the 4750 and 24 balls on the 4900, half of which are feed balls and half are backup. The left side box feeds twine to the left side knotters, and the right box feeds twine to the right side knotters. A diagram detailing the threading procedure through each box is located on the inside of each twine box. Remember that the twine balls that supply the needles are used at about twice the rate of the twine balls that supply the knotters. In order to get the best quality hay from the 4750 or 4900, it's important that you allow the hay to cure uniformly and completely. Your operator's manual contains an important section called Quality Hay. This section contains some valuable techniques to assist in obtaining the highest quality hay. The 4750 and 4900 should be inspected periodically, usually as you are lubricating the machine, to check for loose hardware, chains, sprockets, bearings, and lock collars to make sure they are tight. Anytime maintenance is performed on the baler, shut off the tractor and set the flywheel brake. The flywheel brake is properly adjusted when, after setting the brake, the tractor PTO is engaged and the slip clutch rotates, but the flywheel doesn't. If the flywheel rotates, adjust by tightening the lock nut on the brake handle. The main drive slip clutch provides overload protection for the tractor and baler drive systems. A properly adjusted slip clutch will dramatically reduce the load placed on the tractor PTO by slipping slightly as the plunger comes over rear dead center. To properly adjust the slip clutch, adjust springs to the dimensions shown in the operator's manual. After an hour of operation, check that the clutch housing is warm to the touch. If hot, the springs need to be tightened evenly. If cool, the spring lock nuts need to be loosened evenly. A flywheel shear bolt protects the gearbox, plunger, and related parts from damage caused by overloads. Only replace the shear bolt with a specially hardened bolt and nut assembly. When a bolt shears, shut off the PTO and tractor. Set the flywheel brake and determine the cause of the breakage. A package of shear bolts and lock nuts is shipped with each baler. Usually after a bolt is sheared, the plunger must move a large flake of hay into the bale chamber from a dead start, and this can cause increased load on the tractor PTO. A successful way to start the baler after a bolt is sheared is to bounce the plunger off the face of the bale so that it can roll backward far enough so that it has some momentum to compress the flake of hay. The stuffer shear bolt protects the stuffer drive and knotter assemblies. When replacing a shear bolt, it's usually easier to turn the stuffer knotter drive sprocket by hand to align the holes in the sprocket and hub rather than using the flywheel to turn the baler over. The bolt should always be installed with a nut on the inboard side of the sprocket to prevent damage to the needle protection rod. A package of shear bolts and lock nuts is shipped with each baler. The stuffer sensor door is located near the bottom of the charge chamber. When a sufficient amount of hay is packed into the charge chamber, it pushes the sensor door down, tripping the stuffer clutch dog arm, engaging the stuffer clutch, and stuffing hay into the bale chamber. Adjustment of the stuffer door is very important to maintain good bale shape. In the home position, the stop bolt should be set to position the bottom edge of the door flush to 80 thousandths of an inch below the top surface of the charge chamber floor. Trip the stuffer by pushing the door down against the stop. Press down on the door with a long screwdriver and check that the clearance between the block and the stop is a minimum of 3/16 inch. The stop can be adjusted by loosening the attachment bolts and repositioning. The reset spring is initially set at 7 inches on the 4900 and 6 5/16 inch on the 4750. This measurement is taken in the tripped position. A longer spring length will allow the stuffer chute to pack tighter before the dog clutch is engaged. A shorter spring length will allow the stuffer clutch to trip when the hay is less tightly packed in the chute. Adjust the spring to be as short as possible and still maintain good bale shape in light hay. The stuffer clutch should only be checked after the stuffer door adjustments are made. Set the stuffer door linkage in the home position. Check that the center line of the disengaging roller is 1/2 inch from the end of the clutch pawl arm. The linkage arm is adjusted with a clevis. The purpose of the stuffer brake is to hold the stuffer fingers in the home position when the stuffer clutch is disengaged. The stuffer brake must slip some each stuffer cycle. If the brake is too tight, it will overheat. If the brake is too loose, the stuffer clutch mechanism will wear prematurely. To check the stuffer brake adjustment, initially set the springs so that they are under some tension and tightened evenly. Lock the drivetrain by setting the flywheel brake. Trip stuffer and then pull down on the stuffer finger tube. The 4900 should take about 120 pounds of pull if the brake is properly adjusted. The brake can also be checked by feeling the plates after the baler is run. The plates should be warm. If they're hot, the brake is set too tight. If the brake runs too tight, excessive wear on the stuffer drive will result. Check the wear on the cam lobe every 500 to 1,000 bales. If the wear is greater than 1/8 inch, replace the sprocket. The charge holding fingers hold hay in the charge chamber until the stuffer clutch is actuated. As the stuffer finger enters the charge chamber, the holding fingers are withdrawn by the cam actuated linkage. The holding fingers remain withdrawn until the stuffer fingers have pushed the hay in the charge chamber into the bale chamber. As the stuffer fingers withdraw, the cam releases the linkage, allowing the holding fingers to re-enter the charge chamber under spring tension. Check that the holding fingers withdraw sufficiently from the charge chamber. The cam action should withdraw the tips of the fingers from the charge chamber by 3/8 to 1/2 inch. Adjust by rotating the clevis to lengthen or shorten linkage. Check that all linkage operates freely and spring tension is sufficient. The baler is timed to coordinate the operation of the stuffer, plunger, needles, and knotter. Each of the drive mechanisms is set from the factory with timing marks installed. Baler timing will have to be checked whenever the drive chain is replaced. With the drive chain off, rotate the stuffer knotter drive sprocket to align the timing marks under the shear bolt to those on the side of the baler. Rotate the stuffer drive sprocket to align marks on the sprocket to those on the side of the baler. Rotate the knotter needle drive sprocket to align marks on the inside of the sprocket to those on the inside of the knotter bracket. Install the drive chain and adjust tension. All timing marks should stay in alignment. To check the timing relationships, trip the stuffer clutch. As the plunger is moving forward, the stuffer fingers are moving toward the charge chamber. The fingers should enter the charge chamber and start a slight upward movement as the plunger has completely opened the top of the charge chamber. The plunger will reverse direction and begin to move back. The stuffer fingers must have completed their upward movement as the plunger begins to close the top opening of the charge chamber. If this relationship is not correct, loosen the drive chain and advance or retard the stuffer drive sprocket one or more teeth. As the plunger continues to move back, the needles should just begin to enter the bale chamber when the top of the plunger knives have passed the needle points by the specification in the operator's manual. The balers have a number of chains which need to be checked and tensioned periodically. Refer to the maintenance section of the operator's manual for specifications. The packer fingers are protected from overloads by a slip clutch. The pickup is driven by the packer finger drive shaft, so if the packer fingers jam, the pickup assembly also stops. The pickup assembly is also protected by a slip clutch. Adjust spring length to specification. Set the pickup flotation height linkage to carry the pickup with the gauge wheels clearing level ground. Set the flotation springs so that the pickup can be raised with 30 to 50 pounds of pull. Spring tension can be adjusted by loosening the lock nut and turning the draw bolt. The plunger is carried by 4 rollers. Watch the plunger rollers at low speed to see if all 4 rollers run the same direction the entire plunger stroke. The 2 front rollers are adjustable up or down. Generally, only 1 roller needs to be adjusted. After determining which roller needs adjusting, loosen the hardware and free the plunger roller shaft retainer. Inside the baler, loosen the plunger roller eccentric bolt. Insert a 1/2 inch breaker bar in the square hole at the front of the eccentric and rotate it as required to raise or lower the plunger roller. The side rollers are used to center the plunger by aligning the needle slots in the face of the plunger with those at the top and bottom of the bale chamber. To adjust, make sure the plunger is centered and at the rearmost point of its stroke. Loosen the mounting bolts on the side rollers and adjust clearance between the side roller and rail to 1/16 inch. After checking roller adjustments, the plunger knives, top and side face brackets, and hay dog clearance can be checked. Plunger knives and side face brackets should have 1/8 to 3/16 inch clearance from the bale chamber. The top face brackets should have 5/32 to 15/64 inch clearance. This clearance is a little larger than the knife clearance because when compressing crop, the plunger will lift some. Check that the hay dogs do not extend past the inside surface of the bale chamber. If the heel of the hay dog is less than 1/8 inch from the inside surface of the bale chamber, the contacting surface should be built up by welding. Also, check that the plunger does not touch the hay dogs. The clamping bolts used on the gearbox crank arm should be checked for tightness after the first 1,000 bales. Bolts should be torqued to specifications in the operator's manual. Because of their unique operation, let's look closer at the Heeston double knotter system. The double knotter system requires 2 balls of twine per knotter, one to supply twine to the top side of the bale and one to supply twine to the bottom side of the bale. The top and bottom twines are tied together in the bale chamber. The bale being formed will have twine along its top, rear, and bottom sides. When the preset bale length is reached, the needle delivers the bottom twine up across the front of the bale. The tucker arm moves up to get out of the way of the needle. The needle continues upward, picking up the top twine from the tucker arm roller. The needle continues upward through the stripper arm slot, laying both twines across the billhook and then into the recess of the twine disc. At the same time, the twine finger moves the bottom twine closer to the billhook. The billhook starts to revolve with both strands of twine. Also, the twine disc starts to rotate downward, holding both strands of twine. The billhook revolves while the tongue raises to receive the twine ends. The twine disc has completed its 90-degree rotation, and the twine is in a position to be severed by the knife. The twine finger returns to its neutral position. The billhook tongue closes, the knife advances, severing both twines. The billhook holds the severed twine ends as the loop is stripped off the billhook by the stripper arm, forming the first knot. The tucker arm moves downward as soon as the needle retracts past it to position the top twine in the path of the twine finger. The twine finger moves in for the second time, picking up the 2 twines being held by the twine disc, and moves them into the path of the billhook as it makes its second rotation. The billhook starts to revolve, picking up both strands of twine. The twine disc starts to rotate downward. The billhook rotates, and the tongue raises to receive both twine ends. The twine disc completes its second 90-degree rotation, and the twine is in a position to be severed by the knife. The twine finger retracts some to provide twine for the knot. The billhook tongue closes, and the knife advances, severing both twines. The twine finger moves in to tighten up the twines and aid in stripping the twines from the billhook. The billhook holds the severed ends of the twine as the loop is stripped off the billhook by the stripper arm, forming the second knot. The upper slacker arm moves upward to remove slack from the twine as the second knot is stripped off the billhook. The monitor flag is now up. As the next bale is formed, the slacker arms and monitor flags will move gradually to the down position. Now the twine disc is not holding the twines. The needles should be positioned in the carriage so they are centered in the needle slots at the bottom of the bale chamber and rubbing lightly on the right side of the needle slots at the top of the bale chamber. To properly adjust the needles side to side, turn the baler flywheel by hand to position the needle tips just below the top needle slots. Center the bottom portion of the needle in the slot by loosening the attachment bolts and sliding the needle side to side. Then bend the needle so the tip lightly rubs to the right side of the top needle slots. This adjustment is very important to ensure that the top twine is properly picked up. For needle front to back clearance, the needle's second roller should clear the disc cleaner by 1/16 inch. To increase this clearance, loosen the top bolts and tighten the bottom bolts. To decrease clearance, loosen the bottom bolts and tighten the top bolts. After the needle is properly positioned, tighten nuts to specs, then tighten the jam nuts. Recheck the needles after retightening the bolts. The needle should be checked at maximum penetration for the clearance at the bottom of the needle guide plates and at the top of the needle mount plates. Clearance can be adjusted by turning the clevis at the bottom of the needle actuating rod. The twine fingers position on the twine from the needles into the path of the billhook. The twine fingers must operate freely, and be set correctly to prevent misties. To set the clearance between the tip of the twine finger and needle, trip the knotter and rotate the flywheel until the twine fingers are actuated. Clearance from the twine finger tip to the needle should be 1/32 to 1/8 inch maximum. To adjust, loosen the attachment bolts and slide the bracket. In the home position, the inner surface of the twine finger should be perpendicular to the needle slot. If adjustment is needed, turn the clevis end of the twine finger rod. The twine finger pivots should be taken off and cleaned regularly, because dirt and crop residue may build up and jam the mechanism. A sticky twine finger pivot may cause all the nuts to miss because all the twine fingers are operated off a common shaft. Since a large percentage of misties are caused by needle and twine finger misadjustment, check these settings before changing the knotter adjustments. The tucker arm rollers must be correctly aligned with the needle tip roller. All arms can be adjusted by adding or removing washers at the right tucker arm shaft bearing. To adjust individual arms, the tucker arm can be bent. Correct alignment is the tucker roller centered to 1/2 roller width to the left of the needle roller. Moving the tucker roller to the left compensates for twine twist, which makes the twine feed to the side. The needle carriage brake adjustment is designed to maintain a constant load on the needle carriage arm during the tying cycle and to hold the needles in the neutral position. To adjust the needle brake, set spring length as shown in the operator's manual. Run the baler through several tying cycles at full PTO speed. Check that the clutch arm is lifted above the disengaged roller 1/8 to 5/16 of an inch. If the clearance is above the upper limit, the brake is set too tight, and the cam lobe and the knotter drive sprocket will strike the clutch arm roller, causing premature wear. The knotter drive sprocket should be inspected every 500 to 1,000 bales. If the cam lobe wear is greater than 1/8 inch, the sprocket should be replaced. If the clearance is below the lower limit, the brake is too loose, and an excessive load will be put on the knotter clutch arm, and will be stopping the knotter and needles without help from the brake. This could also jam the knotter trip arm linkage, causing excessively long bales. Check this adjustment first if an extremely long bale is made. The knotter trip arm linkage adjustment can affect the knotter engagement and bale length. In the home position, the disengaging roller should have 1/16 to 1/8 of an inch clearance with the back of the clutch arm notch. Adjust with the clevis. The needle protection linkage operates off the plunger drive system, so if the stuffer shear bolt breaks during the tying cycle, the needles will be removed from the bale chamber. Adjust the needle protection linkage after being sure the needles are adjusted and the baler is timed. Be sure the needle carriage is in its home position. If not, cycle the knotters at full PTO speed. Manually rotate the flywheel until the protection linkage is pointing fully forward with the linkage bisecting the shaft. At this point, adjust the turnbuckle so the linkage is tight, but does not pull the needle carriage forward more than 20/1000 of an inch at the bearing. Failure to maintain this adjustment may result in damage to all 6 needles. Twine tension is regulated by the upper and lower twine tensioners. Incorrect twine tension will cause several knotter malfunctions. If the tensioners are too tight, the knots will look frayed. If the tensioners are too loose, the knot pigtail will be short, or the knot will be loose, and may untie later in the field. Tensioner adjustment nuts should be adjusted to get 15 pounds of pull on the twine. The twine holder holds the twine in the twine disc. The twine holder springs apply pressure and allows a certain amount of twine to slip out to make a knot. The knot pigtail length should be monitored. If it is less than 1 inch and knots are pulling apart, loosen the twine holder 1/6 of a turn at a time. If the pigtails are too long and the knots are hanging on the bill hook, tighten the twine holder 1/6 of a turn at a time. The twine disc works with the twine holder to apply tension to the twine as the knot is being tied. The needle places the twine in the notch of the twine disc, and the disc rotates 1/4 turn to hold the twine. Set the twine disc in relation to the disc cleaner. If the notch is too far advanced, the twine disc will not pick up the twine from the needles. If it is retarded too far, it could allow twine to wrap in the bill hook shaft, or allow the bill hook tongue to miss the twines. Check the operator's manual for proper adjustment. Adjust the twine disc notch by loosening the nut in the worm gear. Tap the end of the tapered worm gear shaft to loosen the worm gear. Turn and hold the twine disc and tighten nut. Recheck adjustment after tying at least 2 knots. The billhook needs to be free from rough edges and burrs, as this can cause the knot to hang up and the twine fibers to be cut. The billhook cam is adjustable and operates under spring tension to apply pressure on the billhook tongue when the knot is being tied. Set the billhook cam leaf spring so that it has a slight preload. The billhook spring tension is not a critical knotter adjustment, and it will not cause misties if it is slightly misadjusted. The stripper arm has a knife which must be sharpened or replaced occasionally for optimum performance. The arm also has a half-moon-shaped notch which rubs against the heel of the billhook when actuated. When the notch does not rub against the heel of the billhook, the twine loop will not be removed correctly, and a poorly formed knot will be made. The stripper arm is made from a malleable cast iron which can be bent. Adjust the stripper arm by bending with a hammer or adjustable wrench. The flange of the stripper arm must travel a minimum of 3/8 inch beyond the end of the billhook. If this travel is insufficient, check for wear on the stripper arm roller or wear on the lobes of the cam gear. Included with the baler is a box of essential parts for proper operation of the knotters. Keep this box with the baler and replace parts as they are used. The 4750 and 4900 balers use state-of-the-art electronics to control bale density and monitor baler functions. When a malfunction occurs, refer to the electronics maintenance section of the operator's manual. The balers use 4 inductive sensors. The baler timing inductive sensor is located in the output shaft of the gearbox. This sensor monitors the shaft speed and compares it to the sensor on the feeder clutch and the sensor on the stuffer knotter drive sprocket. Adjust these sensors to 20 thousandths to 30 thousandths of an inch from the sprocket teeth. The stuffer cycle inductive sensor clearance must be set to 10 thousandths to 20 thousandths of an inch. The balers have 3 reed-type switches to monitor the knotter and needles. Misadjustment of these switches could show false knotter and needle readings. Adjust these switches from 125 thousandths to 250 thousandths of an inch away from the actuator magnet. To check that the electronic system correctly operates the baler hydraulic system, a load decrease and load increase test can be performed. To check that load pressure can be released, set the plunger load to zeros. Lock on the tractor remote valve. Pass a knife blade across the stuffer cycle inductive sensor about every 2 seconds. Listen for the load decrease solenoid to click. The stuffer dot should flash each time the knife is passed by the sensor. The load should scan zeros, and the pressure reading on the console should decrease. If the crop is in the bale chamber, the tension cylinders will extend. To check that load pressure can be increased, set plunger load above 140. Follow the same procedure as before. The load will still read zeros, the pressure should increase, and the tension cylinders will retract slightly. Included with the baler is a box of essential parts for proper operation of the baler electronic control system. Keep this box with the baler and replace parts as they are used. The baler should be stored at the end of the season with all the hay removed. The best way to remove the hay from the bale chamber is to make a very loose bale so that it is easier to pull out. Leave enough hay in the field to build from 1 to 1.5 bales. Set plunger load to 0. Set the stuffer to continuously cycle by clamping the stuffer door down. Set the knotter trip arm to make short bales, about 3 feet long, as these are the easiest to remove from the bale chamber. Bale at a slow ground speed, and when the tight bale is pushed out, manually trip the knotter to tie off the remainder of the loose hay in the bale chamber. The short bales can then be pulled from the bale chamber. Even though the bales are loose, it still may be necessary to pull the bales out of the chamber by sliding a bar under the twines on one end of the bale and use a chain to pull out the bale. Clean the loose hay from the baler, especially in the knotter area. It is better to use compressed air rather than a pressure washer, as water tends to accelerate the formation of rust and can cause some of the moving parts to stick. Thank you for the confidence you've shown in Heeston by purchasing a 4750 or 4900 baler. Remember to read your operator's manual thoroughly in order to properly maintain your baler. A comprehensive service manual is available on the 4900 for more technical information. Through our network of Heeston dealers, we will always be available to assist you in your service and parts needs. This video is not intended as a substitute for your operator's manual. The operator's manual should be carefully read, paying particular attention to the safety instructions. Safety instructions should be followed at all times. Heeston suggests you view this video before taking your baler to the field, and once again after familiarizing yourself with the machine. An index is provided on the back cover of the video to help you find specific information.